When people think of forests in the Pacific Northwest, they usually don't think of our deciduous canopies. But deciduous trees in our region, Puget Sound, Western Cascades, Western Oregon, Western Washington, in these locations, deciduous canopies can be a really fundamentally important part of the ecosystem, and especially with regard to epiphyte loads. We're looking up the branches of a moss tree right here, which just has incredibly deep epiphyte loads. These moss mats are 3 to 4 inches deep, around 10 centimeters or so, and they can provide important habitat for other forest organisms. As we look down this small non-fish-bearing riparian drainage, you see a majority of the canopy here is occupied by deciduous trees. Not all are maple. Alder is another common dominant in our forests, and there are a number of alder trees in here as well. As we go into the winter months and leaves start falling in greater abundance, the forest floor will become littered in a deep mat of easily decomposable leaves from these species. This leaf material addition to the forest floor can provide rapid recycling of nutrients and a really unique environment for forest floor dwelling organisms like newts and arthropods like beetles. Decomposition processes in the neighboring conifer forests are likely to be slower. The needles are tougher, and they fall more regularly throughout the summer rather than all in one punch like these deciduous trees are about to do. Right now it's early October as I'm filming this. And as we go into the fall, what was a darkened, dense canopy will become a light canopy, and this will be the location in the forest where you're most likely to find light in the middle of the winter. At the same time, processes that are taking place on the forest floor will really ramp up as leaf litter from these individuals starts hitting the ground. These big leaf maples are in a couple different stages of decay, some of them having just fallen and some of them having fallen a while ago. And in fact, on the center one, you can see some tar spots that have already developed on this big leaf maple before it even fell out of the canopy. Let's walk along and see if we can't find some more. As we get further into fall, you'll notice a really odd phenomenon. Sometimes maple leaves are likely to fall green, but many of our maple leaves will start falling brown and yellow. At the same time, you'll see green leaves falling from alder, and generally late in the season. Why is that? Alder trees, which can make up a large component of our deciduous canopies, are nitrogen-fixing tree species. Well, that's a bit of an exaggeration. They actually have an association with a nitrogen-fixing bacteria, which provides them a free source of nitrogen. A large amount of the nitrogen required by plants is required by chloroplasts. In particular, it's required by an enzyme within the chloroplast that's involved in fixing carbon dioxide. When the trees are no longer photosynthetically active, they no longer need that chloroplast or that nitrogen in the leaves, and most trees will resorb that nitrogen. They will free it up and resorb it back into their stems, up to 70% of the nitrogen that's in leaves, and then flush that nitrogen back out again when they need it in the spring. Alder's a little bit different. Because alder has this association with a nitrogen-fixing bacteria, it doesn't need to recycle that nitrogen internally. And so, instead of having leaves that are falling brown or yellow as the fall happens, where nutrients have been resorbed prior to leaf fall, alder leaves tend to fall green, recycling the nitrogen from their chloroplasts and their photosynthetic machinery directly back into the soil and enriching the soil with nitrogen. Another important consideration when it comes to deciduous trees is how quickly wood from deciduous trees can often decompose. But many of these deciduous trees get very punky and decompose really rapidly once they hit the forest floor. So it's another reason why when we think of deciduous trees, even relatively decent size logs like the one I'm touching here, you can see it doesn't make for very great carbon storage on the forest floor because it decomposes so quickly. Now, there are important ecological benefits to decomposing quickly and recycling nutrients and carbon back into the soils. But what that also means is that there's a large amount of energy stored in a log like this that's rapidly getting decomposed, and that carbon is going to go back up to the atmosphere. By comparison, even a relatively old Douglas fir snag around the same diameter remains hard for a long period of time on the forest floor.